So students, let us look at the next section. This section contains paragraph based questions. For every paragraph there are 2 questions which has only one correct option. Okay, so let us start with question number 33 now. We have been given a hypothetical elementary parallel reaction in which x is converting into 2y and 3z with a rate constant of k1 and k2 respectively. The t half for the first conversion is 15 hours and the t half for the second conversion is 10 hours. So the reaction starts with 10 moles of x only. So from the above information we have to comment on the half-life of the overall reaction. So students, we know that the net K can be written as equal to K1 plus K2. Okay. Now this can be written as ln2 by T half net, which you have to find out. It is equal to ln2 by T half 1 plus ln2 by T half of 2. So this can be simplified to give us 1 by T half is equal to 1 by 10 plus 1 by 15, which on simplification gives us a T half value of equal to 6 hours. So students, the option which we have to mark for this question is option B. Let us look at question number 34 now. So we have been given that at an instant the moles of Y formed in the reaction was found to be 2. Then at that instant the moles of X and Z present in the reaction mixture are respectively. Students, we can find out the value of the ratio of moles of Y is to Z. So moles of Y formed upon moles of Z formed. So Y is formed at the rate of twice the rate of reaction, so 2K1, and Z is formed 3 times of the rate of reaction. Okay, 3K2. Now this K1 is to K2 can be simplified as T half 2 is to T half 1. So 2 by 3 into T half 2 upon T half 1. So which is equal to 2 by 3 into 2 by 3, as the T half of the second reaction is 10 hours and the T half of the first reaction is 15 hours. So 10 by 15 will give us a value of 2 by 3, and this value shall be squared and we have a value of 4 by 9. So moles of Y to moles of Z present in the reaction mixture is given by 4 by 9. And we have another equation which is basically nothing but the conservation of mass. So moles of X plus moles of Y by 2 plus moles of Z by 3 at any instant, it shall be equal to the moles of A which was taken initially, that is equal to 10. So we have been given the value of Y. The value of moles of Y is equal to 2. So X plus 1 plus Z by 3 equal to 10, and we can find out the value of Z from this expression. The value of Y is equal to 2. So the value of Z is equal to 9 by 2, which is equal to 4.5, and the value of X is equal to, so the value of X is equal to 7.5. So the moles of X present is 7.5 and the moles of Z present is 4.5 at that instant where the reaction mixture contains 2 moles of Y. So the correct answer for this question is option C. Let us look at the next paragraph now. Assume a hypothetical cubic crystal lattice named JEE centered cubic with the following characteristics. So some characteristic related to the lattice is given to us. Let us look at them and try and figure out what the examiner is interested in. So first, an atom is present in each corner of the cube. So students, the contribution of that to the cube will be equal to 8 into 1 by 8, that is equal to 1. Let us look at the second option. At the center of 2 pairs of opposite faces, an atom is present. So there are 6 faces and it is said that there are atoms present at 4 face centers and their contribution is half each. So that will be another 2 atoms. Let us look at the third option now. At the center of each edge of the cube, an atom is present. So there are 12 edges and the contribution of each edge to 1 cube is 1 upon 4. So that contributes another 3 atoms. An atom is present at its body center, so which is 1 itself. So the examiner is interested in knowing how many atoms are effectively present per unit cell in this hypothetical crystal lattice. So that is 7. So the answer which we have to mark for this question is option A. Let us look at the next question now. Question number 36. An element having JCC structure has a cell edge of 120 picometers. The density of the element is 6.8 gram per centimeter cube. How many atoms are present in 408 gram of the element? So students, we know that the density of any cell is given by the Z value, which is the number of atoms present in the unit cell, into the molar mass upon Na upon A cube, where A is the edge length. Now this density is given to us in terms of gram per centimeter cube. So we have to take that into account and we have to convert this A value into centimeters. So the value of Z we had already calculated before. That was equal to 7 into m naught upon Na into A cube. The value of A is 120 picometers. So it can be written as 1.2 into 10 to the power minus 8 centimeters. So we need to cube this value, 1.2 into 10 to the power minus 8 cube. So from here we can find out the value of m naught, which is the molar mass. So molar mass is equal to D into Na into 1.2 into 10 to the power minus 8 cube upon 7. So we can find out the number of moles present in 408 gram of the element. So N is equal to 408 upon the m naught value. So the number of atoms will be equal to N into Na. So we have 408 upon D into Na into 1.2 into 10 to the power minus 8 cube into Na. So if we put the value of Na over here and we put the value of density, we will have the total number of atoms to be equal to 2.43 into 10 to the power 26. So which is given to us in the C option. So students, the answer which you have to mark for this question is option C. So this is it for today guys. I hope the solutions were clear to you. Thank you.